Welcome to a special 15-year anniversary episode of Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office, or NNCO. Today, it's my pleasure to welcome Dr. Shawn Hearne, Director of the Center for Nanophase Materials Sciences, or Cnms, at Oak Ridge National Laboratory. Prior to his current position at Oak Ridge, Shawn was co-director of the Center for Integrated Nanotechnology at Sandia National Laboratories. Both of these centers are part of the Department of Energy's user facilities, or nanoscale science research centers. Shawn, thank you so much for joining us today. To get things started, can you tell us a little bit about yourself and how you first got involved in nanotechnology?
So I really started life being trained as a commercial pilot. But along the way, I actually discovered that my real love was physics. And so with that, as I was combining this interest in flying and interest in physics, it really led me to being interested in materials and applied physics specifically. And as I found that to be the most rewarding area for me, that very naturally led into nanoscience. As in the sort of late 90s and early 2000, nanoscience and nanotechnology was just starting to be up and coming. And there was a lot of interesting new materials that were being developed as part of these nano initiatives. And so that's really where I had my focus and spent much of my science career.
So you're currently at Oak Ridge, but I know that you spent some time at Sandia. When you look at the projects that are ongoing, can you comment on the ones that are most exciting to you?
What I find really exciting is this transition from work in the laboratory to being something that's impactful on society. One of the projects here at Oak Ridge that was actually just recently licensed by a startup company is around using carbon nanospikes to convert CO2 into ethanol. And the ability to do this is really remarkable as it can directly impact the world we live in, right? There's a crisis with too much CO2 being created and finding ways better than just stuffing it into the ground. Are there ways that we could actually use CO2 to the benefit of society is a particularly important activity that we should be working on. So this is just sort of one area which I'm very excited about because of this feedback loop of being able to study something in fundamental science. So this creation of, in this case, carbon nanospikes. And these carbon nanospikes, you put them in a liquid environment, you apply potential, and they form an electrochemical gradient where the tip is a high field area. And it's at these high field areas that you can now get this reduction of CO2 into ethanol. So this is just one of the many examples out there of nanotechnology. Actually, I'll digress for a quick moment. You know, nanotechnology has really been around for thousands of years. One of my favorite examples is Damascus steel. So Alexander the Great was claimed to have had a Damascus steel sword, and they were known for their incredible strength and hardness. But it wasn't until around 2006 when the team discovered that Damascus steel gets these mechanical properties, these fantastic properties, from carbon nanotubes being embedded. So though we only recently discovered how to do it, it's been actually involved in our society and impacting the world, our world for thousands of years.
I want to pick up on the comment you made about the nanospikes, the carbon nanospikes being licensed to a small company. Now, was that a company that was doing work at Oak Ridge, or was that a technology transfer outside of the user base?
It was a technology transfer from outside of the user base. So this is a small business. I believe they're located in Louisiana, and they recognized the technology and decided that it would be a great way for them to improve the possible ways which they have for converting CO2 into useful products.
Can you provide any examples for how research that's being done at CNMS is being transitioned into the private sector?
Certainly, the nanoscience research centers, which CNMS is one of them, typically have somewhere between 5 and 10% of the users are industrial users. So these range from small companies to very large industries that they may or may not have in-house research capabilities. So they partner with the nanoscience research centers in order to really explore some area of fundamental science. And it's free for anyone to use these nanoscience research centers with the understanding that the science that's discovered gets published, essentially for non-commercial activities. It's for this generation of knowledge for the world. So that's a fraction of the user base. The vast majority of the users that come to the nanoscience research centers are actually associated with universities. So typically it's the faculty member, the professor that puts in the user proposal to have access to one of these nanoscience research centers. And then they'll send a graduate student very often or a postdoc that'll come and perform work here at the Nanoscience Center. And that work it could be coming for a single day to run an experiment, or it could be coming for a number of months to really dive into a problem. And actually, we've even had students that have come and done their entire thesis, so all of their dissertation work at the nanoscience research centers. So there's a number of different ways for collaboration, a number of different types of groups that come here. Also, the other national laboratories come and perform work at these user facilities. So as we say, it's open to the world to come and perform science for free.
So at the onset of the NNI, one of the challenges that was recognized was the ability to have access, as you mentioned, to cutting edge tools. And often these are too expensive for individual research groups or universities to buy on their own. Can you share your thoughts on some of the advancements that have been made in characterization or fabrication tools that researchers have access to through centers such as your own?
Absolutely. You really hit the nail on the head. The user facilities, it's about, for one, having access to the scientific knowledge. So the staff that we have at the nanoscience research centers, they're really dedicated to developing new capabilities which they can offer to the community. So be that new scientific techniques or tool sets. One of the areas where I've seen just incredible impact is around electron microscopy. Oak Ridge and Cnms has spent a lot of time investing in and understanding EELS. So this is electron energy loss spectroscopy, which is associated with a transmission electron microscope. And this particular technique, we've continued to evolve and make it more sensitive. And recently we've pushed EELS to the point where we can now look at a single monolayer of atoms, and we can query individual atoms and not just be able to tell their atomic species, but we can actually look and identify their isotope. So it's an amazingly sensitive and refined technique where you can now, I'm always awestruck by the ability to, for one, see individual atoms, but now to be able to fully characterize it. And then as an expansion off of that, using these electron microscope techniques, we're now able to essentially move atoms around. So pick them up as they may be with the electron beam and move them through the material and place it where we want it. So we can identify individual atoms, we can tell what their chemical makeup is, what their isotope is, and we can also pick and place them where we want them within the material. And it's an incredible confluence of capabilities that we have here at the nanoscience centers. And this is because of that dedication to being able to purchase very expensive tools, be able to modify them in-house, give them unique capabilities, and have the staff here which are able to do that and then interface with the community to perform the science.
So as the NNI is celebrating the 15-year of the signing of the 21st Century Nanotechnology R&D Act that really established the NNI, it's giving us an opportunity to reflect on how far nanotechnology research and development has advanced. And you mentioned the example of the capabilities of EELS and how far it has come. But nanotechnology, of course, encompasses so many different fields. What is the area where you feel there's been the most significant advances, or the advances that you're most excited about?
Well, so in terms of advances that have happened over this decade, there's no debating when you look at computers. The current node for Intel is the 14 nanometer node. So you're looking at a handful of silicon atoms that are defining the structures and the transistors that are in the current generation of computers. Another area where you don't have to look very hard at is energy storage, so batteries. Looking at nanoparticles in the anodes and looking at different electrolyte systems, and simply just nanostructuring of both the anode and cathode and the polymers that are used as separators. These are tremendously impactful areas that we're continuing to see advances. I certainly don't think that we've reached the end of where nanotechnology will be impacting energy storage, or as you start to look at other areas such as catalysts. Right? So the catalyst is an incredibly important area. We talked a little bit earlier about using carbon nanospikes as catalysts for doing this CO2 conversion. But it's also incredibly important in areas such as ammonia. The creation of ammonia is, it impacts food that we eat in the terms of fertilizer. Also, thinking more broadly, just in terms of energy and the environment. There's so much work that still needs to be done for lightweight materials, for proving that the strength and mechanical properties of them, just like the Damascus steel example, that now as we're getting good at placing atoms where we want them. And so we spent the first 10 years of trying to understand what nanostructures are and how you can make them. And now we're starting to reach this point where we're placing atoms where we want them to develop new mechanical properties or chemical properties or electrical properties in these structures. So being able to place them now and make new systems and new devices is what I see where that forefront is. And it's not just being able to place these and making one active carbon nanotube, but really that forefront is going from making one interesting nanoparticle or nanostructure to now scaling that up to a point where we can do something useful with it.
So as we've had the opportunity to have conversations with folks about the NNI and reflect, one of the comments that we hear quite frequently is that the NNI has brought disparate researchers together. From the lab perspective, do you see that the nano centers bring people from different backgrounds together to address common interests?
Absolutely. I think you made a very important point there. Nanoscience really bridges across so many different areas, be that chemistry, be it physics, be it electrical engineering. When I walk around the building here, I don't want to say it's impossible to tell what the individual's background is, their training, because we're all working on ultimately the same sort of things, working on exploring these different nanostructures, nano devices. And it takes a wide variety of backgrounds to do that. There's a lot of, you see this more generally in the materials science field as a whole. It really is a nexus of different disciplines that takes advantage of the skill sets of each one of these different disciplines and brings it together. Now, one of the newest groups that you see really getting pulled into the nanoscience community very strongly is the data analytics. As we're developing new tools for studying nanostructures and nanomaterials, we're now getting just such a tremendous amount of data that we're relying on experts in data analytics and data handling and data processing to really tell us what is there to discover. So we're even pulling into a much larger group. I'm sure that will continue to occur as nanoscience evolves and expands what areas it's impacting.
So as we look to the future, you mentioned already the carbon nanospikes and the ability to help address carbon dioxide, which is clearly a significant world challenge. Are there other areas that you see a critical need to benefit society as a whole where nanotechnology is going to play a critical role?
Absolutely. As you mentioned, more broadly, the energy landscape is a critically important area where nanomaterials is having an impact and needs to expand its impact. The best electron that we use is the one we don't use, right? So in terms of efficiency, there's tremendous gains to be made still there using nanomaterials, as there is on creation of energy. One area we didn't really talk about is biological systems. There's been a tremendous amount of work in nanoparticles or nanostructures in the biological world, and that's an area where, in terms of medicines, in terms of mimicking of biological systems, there's still a lot of work that can be done and a lot more impact to be had.
So, Shawn, I want to thank you so much for taking the time to talk with us today. Do you have any closing thoughts that you'd like to share with our listeners?
We've touched on a number of these different aspects of the user facilities that came out of the NNI. And, I want to encourage people to take a look at these different user facilities that are out in the community, whether they're funded by Department of Energy or National Science Foundation, because all these facilities have been funded for the scientific community to come and use. So, we often talk about here at the Nanoscience Research Centers that we are free science. Come to us and let us help you advance what you're working on. That's really the message that I want to make sure that your listening audience walks away from. We're facilities, we're here, we're paid for, we're open for the community to come and do science that ultimately improves the world that we're living in.
Thank you for joining us today for this special 15-year anniversary edition of Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov and check back here for more stories.